G'day! So, in this example here, we're going to be looking at proving independent events. So, this is actually just some proof on how they work and if they are so. So, with this question here, we've got a die is thrown and a number is recorded. Okay? Event A is an even number. So, event A, even number. And event B is a square number. Okay? Show that these are independent. So below I have just some information on independent events if you just quite can't recall. So two events A and B are independent if the occurrence of one event has no effect on the probability of the occurrence of the other. So theoretically, when you're rolling a dice, the number before that you roll doesn't actually affect the next number after. So theoretically, we should know with a dice that these will be independent, but we need to prove this mathematically. So first, we're just going to look at our events A and B. So A. Event A is an even number, so we're just presuming this is a six-sided dice. So our even numbers on the dice, we have our set. This could be 2, 4, or 6. That's our set there. Okay, I'll just get rid of this. It's going over a bit of information that we need. Okay, event B is a square number. So just remember though, 1 squared is 1, so technically 1 is a squared number. And then 2 squared, that's 4, so that's going to be the other squared number, 4. Okay, 3 squared's 9, and 9's too high, so that won't fit on the dice. So, now, events A and B in our bit of information here are independent if and only if. So, the probability of A intersect B, or A and B, is equal to the probability of A times the probability of B. So now we need to work out these probabilities of these occurring. So, first, the probability of A, if we have 6-sided on a dice, okay, and we've got 3 options here. This is 3 over 6, which is equal to a half. Okay, so now our probability of B occurring, we've got 2 numbers here, and there's 6 sides on the dice. So this here is then 1/3. So we can actually work out our probability of A times probability of B. Okay, and this here is equal to a half times a third, which then will equal to 1/6. So now we know the value that we need to prove that it equals. Alright, now we need to find our probability of A intersect B. And we need a way of proving that this here is going to equal 1/6. So how we do this, we actually just need to sort of break out our options that we have. Okay? So first, we need to figure out our total outcomes, okay, of rolling one event after the other. So with this, I'm just going to draw this up as a set. So first, for event A, we roll a dice, say we get a 1, okay? And then we have event B, and say we get a 1 for that. So that's one different outcome that we can get, okay? And then you can continue this with each one. So just remember this first one, this is like event A happening, and this is the event B, the roll you get for that. And you continue on, this is A, and this is B, and this is a different outcome here. So we can continue this you could continue in writing it. Oh geez, I forgot 5. Can't even count now. So you can continue writing these out, but for example, we've got 6 here, okay, we've got 6 different outcomes, alright, and we've got 6 different numbers, so you can actually just work this out by doing 6 times 6. So our total outcomes is going to be 36, okay? So, now we just need to work out our A intersection B. So all our different outcomes for this. Okay? So we just actually need to list these out. Okay? So our first one, and we've got, just use your numbers that you've got up here, okay? And just do it in a methodical order. So I'm going to do outcome 1 first, or A, so 2, and then we can have 1. Alright, then we've got 2, and we can have 4. Alright, next one, we've got 4 for our outcome, or our event A. Just remember, set these up in the same way as event A and B, okay? So this first one's event A, this second one's event B, okay? So we set this up, we've got 4, and then we've got 1. For event A, we've got 4 and 4, and I'll just finish this off. 6 and 1, and 6 and 4. Okay? So, A and or intersect B, we have 1, 2, 3, 4, 5, 6 outcomes. Okay? So this is how we've gone about proving this. Alright? So probability of A and B, or intersect B, is just our amount over total. So with this, we have our amount of 6, our total amount of outcomes is 36, and then that simplifies down to 1/6. Alright, just going to scroll down. So now we've actually proved that 1/6 here is equal to and the same as 1/6 there, as we just did. So we've actually proved that this question is. So probably just make a statement. Sorry, my ordering there wasn't very methodical on how everything is. So just make sure the events are independent, just writing a little statement. As we proved, that the probability of A intersection B is equal to the probability of A times B. Okay? So it's always good just to show a little statement of what you've done as well. So hopefully that helps with just what is an independent event and how you can go about proving that something might be independent. Alright, so good luck with that.